Welcome back to another video in which we will solve O-Level Mathematics Paper 2, Variant 2 for May-June 2019. Question number 1 is the table below shows the cost to visit a zoo. So adult ticket is $26, child between the age of 5 to 16 is $15.50, and child under 5 is free. On 30th April, Mr. and Mrs. Ferruggio and their three children aged 12, 8, and 3 visit the zoo. What is the total cost for the family? So you have two adults and two children between age of 5 and 16 here, and one child who is aged 3, which is under 5. So total cost will be 2 times the tickets for adults, for two adults, plus two children tickets between age 5 to 16, so 2 times 15.50, and then this child here who is 3 years old will get free entry, so that is not added to the total cost. So 26 times 2 is 52, plus 15.5 times 2 is 31, and if you add them together you will get $83. So your total cost here is $83. Part B is in May, the cost for the child is not changed. The cost for an adult is reduced by P% to $22.10. Calculate P. So let's first calculate the cost reduction in dollars, and then we can calculate the P percentage. So cost reduction is how much? Initial cost was $26. And then the final cost in May is $22.10. So 26 minus 22.1. So $3.9 is the reduction in cost. So P is the percentage decrease in cost. So percentage decrease will be the decrease in dollars, which is 3.9, divided by the initial cost, which was $26, and then multiplied by 100. So 3.9 divided by 26 into 100. So this is 15%. So the cost for the adult ticket decreased by 15%. So your value of P is 15. Part 2 is, in May, the Ferruggio family visit the zoo again. Calculate the percentage reduction in the total cost from April to May. So the total cost in April is $83. So first we need to find the total cost in May. So the total cost in May is 2 times the adult ticket cost. So the adult tickets cost $22.10 in May. So this is 22.10. The children tickets are unchanged, so this will remain same. So this is 2 into 22.10 plus 31. So this is $75.2. So decrease in cost is how much? 83 minus 75.2. So 83 minus 75.2 is $7.8. So now we need to calculate the percentage reduction. So percentage decrease or percentage reduction will be the reduction in cost, which is $7.8, divided by the initial cost, which was 83 in May. So 83 into 100. Sorry, 83 in April, not May. May is 75.2. So you're moving from April to May. So your initial cost is 83 in April. So this is 7.8 divided by 83 into 100. So this is 9.397. So I will write up till 3 significant figures. So this will be 9.40%. So this is the percentage reduction in cost for this family in May. Part C is the family arrived at the zoo at 10:50 a.m. and they stayed at the zoo until 4:25 p.m. How long in hours and minutes did they spend at the zoo? So they left the zoo at 4:25 p.m. So left zoo at 4:25. So 4:25 p.m. if I convert this into 24-hour clock, I'll add 12 to this 4, so I will get 16:25. And they arrived at zoo in the morning at 10:50. So if I subtract these two, I will get the time that they spent at the zoo. So I cannot subtract 50 from 25, so I'll have to carry. This will be 15, and I'll add 60 minutes to this 25 minutes. So this will be 85. 5 minus 0 is 5, 8 minus 5 is 3, and then 15 minus 10 is 5. So they spent 5 hours and 35 minutes at the zoo. Part 2 is the zoo holds daily shows about different animals. So you're given the show about the animal and the time at which the show happens. The family go to as many shows as they can during their visit. Each show lasts 35 minutes. How many minutes do they spend at these shows? So first we need to find how many shows did they go to. So the starting time is this. So let me draw another column with end times for all the shows. So each show is 35 minutes. So this will end at 10:35 a.m. 11:30 start time will end at 12:05 p.m. This will end at 1:05 p.m. 1:45 will end at 2:45. Oh, sorry, 2:15 and 2:20. 2:20 p.m. This will be 3:35 p.m. and this will be 5:05 p.m. So they arrive at 10:50. That means they cannot go to this show, which is at 10 a.m. So the first show they go to is at 11:30 a.m., which ends at 12:05. Then they go to the next show, which is at 12:30, which ends at 1:05. Then they go to the next show, which is at 1:45, which ends at 2:20. And then they go to the next show, which is at 3 p.m. So they go to this one as well, which ends at 3:35. And they cannot go to this show at 4:30 p.m. because they leave the zoo at 4:25. So they leave before this show begins. So this is not the show. So family attends one, two, three, 4 shows. 4 shows. Uh, time spent at shows will be 4 times 35, which is 4 into 35 is 140 minutes. So they spent 140 minutes at these shows. Question 2 is the table shows the average monthly temperatures degree Celsius in Tokyo and in Sydney 1 year. So you have temperature in Sydney, temperature in Tokyo for January, February, March until December. Complete the scatter diagram. The first 8 points have been plotted for you. So these are the points that have been plotted. On x-axis, you have temperature in Sydney. On y-axis, you have temperature in Tokyo. So in September, the temperature in Sydney is 16 and Tokyo is 23. So 16 will be 15, 16. 16 will be this one because each, so this is a change of 5 and 10 blocks. So each small block is 0.5 degrees. So if this is 15, 16 will be 2 blocks towards the right. And then Tokyo is 23. So I'll go up. This is 20. Again, on y-axis as well, 2 blocks represent 1 degree. So this is 21. This is 22. This is 23. So this point is 16 on x-axis and 23 on y-axis. The next one is 18 and 18. So 18 will be this line, and this is 20, and then 18 will be this point here. So this is 18, 18. 20 and 12. 20, 10, 11, 12. And then 21 and 8. 21 is this is 10, 9, and 8 will be here. So this is 21 in Sydney and 8 in Tokyo. So we have completed this scatter diagram. Part B is what type of correlation is shown by the scatter diagram. So this is a negative correlation because if temperatures in Sydney are increasing in this direction, if you go in this direction, the Y values or the temperature in Tokyo, they are decreasing. So it's a negative correlation. Part C is draw a line of best fit. So let me bring in the ruler here. So I'll try to draw a line such that I have equal number of points on either side and kind of passes through the center of all this scatter plot. So if I draw something like this, so I have 1, 2, 3, 4, 5 points on this side, and then 1, 2, 3, 4 points, which is also fine. So the line could go through these 2 points, these 3 points. So let me mark this point here and this point here, and let's draw a straight line. So this could be our line of best fit. It passes through these 3 points. You have 1 point on this side, then this point on this side. For this, you have this. So these two are like close to the line, and then for each point, you have 4 on this side and 4 on this side. Although this is slightly away from the line as well, but that is okay. So this will be your line of best fit. The next part is the following year, the average temperature in Sydney during May was 15 degrees Celsius. By using your line of best fit, estimate the average temperature in Tokyo that May. So in Sydney, we are given the temperature is 15. So if we go up at X value 15, we will check where it intersects our line of best fit. So it's this point here, which is this line. So the temperature in Tokyo will be this one, which is 20, 21, 22, 22.5. In fact, you can go one up as well. I think this, I mean, both are fine. You can also argue that this could be the better point of intersection. So we can write any values. 22.5 is fine as well. I think 23 degrees Celsius should work as well, but you have to make sure you get the intersection point of this vertical line, which is 15 degrees Celsius in Sydney. So the Tokyo temperature is 22.5 degrees Celsius when the X value is 15. Question number 3 is represent the inequality minus 3 x is less than greater than minus 3 but less than equal to 2 on the number line below. So I'll draw a line from this point, which is minus 3. Let me start a little to the left here up till this point, which is 2. So then you will draw circles here. So since minus 3 is not included, this will be a hollow circle. You won't fill it. 2 is a possible value since this is less than equal to sign. So the circle here will be filled to show that this is less than equal to, this is just greater than. There's no equality here, only inequality. Part B is find the three inequalities which define the shaded region in the diagram. So these are the three lines, this one, this, and this, which are the boundaries for this shaded region. So this is x equals to 4. So the shaded region is towards the left. So this will be x is less than equal to 4. This is y equals to 0, which is the x-axis. So this is above this line. So this will be y is greater than equal to 0. So I'm using equality as well, greater than equal to, because these are solid lines. And then you can find the equation of this line. So let's first find the gradient, which will be, so this is the rise, this is the run, or delta y over delta x. So this is 2 over 4. So the gradient is half, and the y-intercept is 0. So y equals to mx plus c is the equation of the line. Gradient is 1 over 2 x plus 0. Y-intercept is 0. So the equation of this line is y equals to 1 over 2x. And since the shaded region is below, so the inequality will be y is less than equal to 1 over 2x. The next part is solve this inequality. So since we need to find the range of values of m, I will divide by 4 on both sides. So this will become minus 12 over 4 less than equal to m minus 2. So this 4 will cancel out with the 4 in denominator, and then I'll have 10 over 4 here as well. So this will be minus 3 m minus 2. So 10 divided by 4 is 2.5. And then I will add 2 everywhere. So this will be minus 3 plus 2. M minus 2 plus 2 will be 0. So this is just m here. And this will be 4.5. Minus 3 plus 2 is minus 1, less than equal to m, and less than uh, 4.5. So your inequality will be minus 1. M is greater than equal to minus 1, but less than 4.5. Question number 4 is ACD is a triangle and ADC is 110 degrees. EB is parallel. These two lines are parallel, EB and DC. And these lines AE and EB are equal in length. Find X, giving reasons for each step in your working. So to find X here, we can first say that angle AEB is also 110 degrees because these are two corresponding angles, given that this line EB is parallel to this line DC. So angle AEB will also be 110 degrees because the reason is corresponding angles. Next, we can say that these two angles are also equal because this is an isosceles triangle. So angle ABE is equals to angle EAB because triangle AEB is isosceles. Isosceles. Okay. So then we can find this angle ABE. So 2 times ABE plus this angle 110 should equal 180 degrees, sum of all the interior angles of a triangle. So this will give us ABE equals to 180 minus 110 divided by 2, which is 35 degrees here. So the reason here was sum of angles of triangle. And then now you have this angle as 35. We can say x plus 35 equals 180 because it's a straight line. Or you can say angles on straight line. Straight line. You can also say angles on straight line. So this will give us x equals to 180 minus 35, which is 145. So this value of x is 145 degrees. Part 2 is given that EB equals 12. So this length here is 12 and DC is 20 centimeters. This is 20 centimeters. Find ED. So this is the length that we need to find. So if EB is 12, then AE is also 12 because these two lengths are equal. And we can see that triangle ADC. So let me mark this triangle ADC and triangle AEB are similar. AEB is this one. Because this angle and this angle is equal, this angle will also be 35 degrees because these are two corresponding angles because these two are parallel lines. So similar to how we showed that these two are equal, these two are equal as well. And this is a common angle in both this green triangle and red triangle. So all three angles are equal. That means they are similar triangles. So using that, we can actually find this length ED. First, we can find AD. So this AD, the corresponding length in the other green triangle is this AE. And these two are also the corresponding length. So their ratios should be equal. So that means AD, this full length AD over AE should equal this length DC over this length EB. So AD is what we need to find. So AD over AE is 12. DC is 20 and EB is also 12. So this gives us AD equals to 20 into 12 and then divided by 12. So AD is 20. So this full length is 20. This length is 12. So ED is what? ED will equal AD minus AE. AD is 20, AE is 12. So ED will be 8 centimeters. So that is how you'll find this length ED. Part B is find the value of A. So how many sides do you have? 1, 2, 3, 4, 5 sides. So let's first find the sum of all angles equals to n minus 2 into 180. N here is 5. So 5 minus 2 into 180, which is 3 times 180. So 3 into 180 will be 540 degrees. So this is 540. And then we can add all these angles and their sum should be 540. So A plus 3A plus 130 plus 80 plus 110 should equal 540 degrees. So A plus 3A will be 4A plus, let's add these, 130 plus 80 plus 110. So this is 320. 320 should equal 540. So this will give A equals to, so first you will subtract 320 from 540. So 540 minus 320 and the answer will be divided by 4. So divided by 4 to get the value of A, which is 55. So value of A here is 55. Part C is PQRS are vertices of a regular polygon. M is the midpoint of PR. PQ is 14 and QM is 7 centimeter. How many sides how many sides are there in this polygon? Show your working. So since it's a regular polygon, if we can find this angle, if I multiply this angle with the number of sides of this polygon, I should get the sum of all the interior angles. Because this is a regular polygon, all of these angles are, and the rest will be equal. So to find this angle, I can actually first find this angle using the triangle PQM. So if you look at triangle PQM, this is 90-degree angle because this is a midpoint. So this line here will be a bisector of this angle, and it will make a 90-degree angle here at this line PR. So if you look at triangle PQM, let's call this angle Y, the red one. So cos, let me write this in blue. So cos of Y will be the base over hypotenuse. So 7 over 14. Let me first write the side. So this will be QM over PQ, which is 7 over 14. So Y will be cos inverse of 0.5. So cosine inverse of 0.5. So this is 60 degrees. So angle PQR is how much? 2 into 60, which is 120, right? So now we can use the equation. So sum of all angles will be equal to n minus 2 into 180. So n is the unknown, and we know that sum of all angles will be 120 times n, where n is the number of sides. So we are basically adding up all these angles which are equal. So 120 times n should equal n minus 2 into 180. So now you can solve this equation in n to get the number of sides. So this will be 120n equals to 180n minus 360. So if I bring this here, this will become minus 60n equals to minus 360, and n will be 60. If I divide here, negative and negative sign cancel out, I will get 6. So n equals to 6. So this polygon, this regular polygon has 6 sides. Question 5 is express as a single fraction in its simplest form. So 3a over 4b minus a over 6b. So LCM of 4 and 6 will be, let's calculate it quickly. 4 and 6 divisible by 2. 2 2s are 4, 2 3s are 6. 2 times 1 and 3 as it is, and then 3 times 1 and 1. So 3 2s are 6, 6 2s are 12. So your LCM here is 12b. 4b is multiplied by 3 to get 12b. So 3a in the numerator will also be multiplied by 3 minus 6b was multiplied by 2 to get 12b. So a will be multiplied by 2 as well. So this will become minus 2a. So this will be 9a minus 2a over 12b, which is 7a over 12b. The next is b square minus 9 over 6 into 2 over b minus 3. So I can write b square, and 9 can be written as 3 square over 6 into 2 over b minus 3. Now I can use the formula a square minus b square is a plus b into a minus b, right? So this will become b plus 3 into b minus 3 over 6 into 2 over b minus 3. This cancels out. This 2 1s are 2, 2 3s are 6. So you're only left with b plus 3 over 3. b plus 3 over 3. Next is solve this equation. So 3x equals to 1 minus, I will open up this bracket, so I will get minus 5x minus 20. If I bring this 5x here, it will become 3x plus 5x, and 1 minus 20 is minus 19. 8x equals to minus 19, and x will be equal to minus 19 over 8. So if you want, you can convert it into the decimal value as well, or leave it as a fraction. Both are fine. Part C is a rectangular card has dimensions 2y by y plus 3 centimeters. A square of side y centimeter is cut from this rectangle. The card remaining shown shaded in the diagram, so this shaded region is remaining after this square is cut out, has an area of 55 centimeter square. Form an equation in y and solve it to find the dimensions of the rectangular card. Show all your working. So uh, we have to form an equation in y. We are given the area of the shaded region. So area of this shaded region will be area of the rectangular card and then area of this square subtracted from the area of this rectangular card, and that should give us, we can equate it to 55 centimeter square. So let's first find area of rectangular card. Rectangular card will be simply the length multiplied by the width. So this is 2y into y plus 3, and then area of square will be area of square equals to y times y, which is y square. So now area of shaded region is area of rectangular card minus the area of the square. Area of square. So area of shaded region is given 55. Rectangular card area is this 2y into y plus 3 minus the area of square is y square. So this is the equation in y, and let's solve this to find the value of y, and then we can easily find the dimensions. So this will be 55 equals to 2y square plus 6y minus y square. So I'll take this 55 to this side as well. So I'll get 2y square. In fact, I'll have 2y square minus y square will be y square plus 6y, and this will become minus 55 equals to 0. And then we can solve this quadratic equation using factorization. So 55 times 1, which is the coefficient of y square, is minus 55, and there's a negative sign. So I need to look for two factors of 55. If I subtract them, I should get plus 6. So 11 times 5 is 55, and 11 minus 5 is 6. So this will become y square plus 11y minus 5y minus 55 equals to 0. So this will be y into y plus 11 minus 5 into y plus 11 equals to 0. This will become y plus 11 into y minus 5 equals to 0. So this will give you y equals to minus 11 or y equals to plus 5. So minus 11 is not a correct value because here you can see that the side of this square is y. So the side length cannot be a negative value. So you can reject this value. So your actual value of y is 5. So now you need to find the dimensions of the rectangular card since you have calculated y. So length of rectangular card is 2y. So this will become 2 times 5, which is 10. And then width of the rectangular card is y plus 3. So this will become 5 plus 3, 8. So dimensions are 2y by y plus 3 centimeters. So 2y is 10 centimeter by 8 centimeter. Question number 6 is the diagram shows positions of two boards A and B drawn to a scale of 1:m. The actual distance between the two boards is 4 kilometers. Part A is find M, giving your answer correct to one significant figures. So you're given that this actual distance between the two boards is 4 kilometers. So what we can do is we can use our ruler here to measure the distance on the paper here. So let me align this and then place 0 at A. So your point B is 5 centimeters from A. So that means if you take the ratios, kilometers ratio centimeters, you have 4 kilometers ratio 5 centimeters. So then we can convert this kilometers into centimeters as well. So 4 kilometers will be 4 into 1000, it will convert it into meters and then multiply it by 100 to get it into centimeters. So this is 400,000. So this will be 5 centimeters in on, you can say, on map ratio centimeters in real world. So 5 centimeters on the map equals 400,000 centimeters in the real world, which is 4 kilometers. So we need to find this ratio, 1 ratio m. So if I want 1 here, so I'll divide 400,000 by 5. So 1 ratio will be 400,000 divided by 5, and this will give me 1 ratio. This divided by 5 will be 80,000. 80,000. And we were asked to give the answer correct to one significant figure. So M here will be 80,000, and it's already, there's only one significant figure here. The rest are zeros, so they will not be counted. So your answer for M is 80,000. Part B is measure the bearing of A from B. So bearing of A from B will be this angle. This is the bearing that this is the angle that we need to measure. That this will be the bearing of A, this point A from B. So since this is greater than 180 degrees and our protractor can only go up till 180 degrees, so what I can do is I can measure this angle here, and if I, let's call this X, and once I find X, I can subtract X from 360 degrees to get this remaining angle. So this makes a full circle, which is 360. So I can subtract X to get this bearing. So let's measure this angle X. So if I place my protractor at this center and align my 0 with the north, and then this is the line going towards A. So this will be 120, 121, 122. So let me move this here. So basically what I'm doing is I'm extending this line so I can get the correct reading. So this is almost 123 degrees. So if your protractor is larger than this line, what you can do is you can use your ruler to extend this line further, similar to how I did this with this like green line here. So again, I'll place it at this center. So you can see that I extended this line further and it intersects this point, which is 123 degrees. So this angle here, X, is 123. So this bearing will be 360 minus 123. So 360 minus 123 will be 237. So this bearing is 237 degrees. So let me just erase this. The next part is a third board is positioned at C. C is on a bearing of 120 degrees from A and a bearing of 195 from B. Find and label C on the diagram. So we will draw two lines, one which makes an angle of 120 degree or which has a bearing of 120 degree from A. So that will be, I'll start my angle from this side. This is the north, and you go clockwise to get the bearing. So let me again use my protractor here. I'll center it on this point A, and now I'm measuring this way. So I'm measuring 120 degrees, right? So my 180 is now my 0 degrees because I'm starting in this direction. So this 90 will be my 90 degrees, then 100, 110, and 120 will be this 60. So let me mark this point here. So this is my 60 degree. And then I have to measure 195 degrees from this point B. So let's erase this as well. So since again my protractor goes up till 180 degrees, there are two options. I can extend this line below. So this will give me 180, and then I can measure 15 degrees more towards this side. Either you can do this, or I can go from this side. So if my bearing like this is 195. The remaining angle is 360 minus 195. So 360 minus 195 will be 165 degrees. So this angle like this will be 165. So I can do that. So let's place it again here at this center. And let me align this with 0. So now I'm looking for 165. So 160 and 165 is this point here. So remember, this angle is 165. That means this angle from this side will be 195. So now I have these 2 points. I'll draw this line. So this point is 120 degrees bearing from A. So let me draw this line here. And wherever these 2 lines intersect, that will be my point C. So let's first draw this. So this has a bearing like this. So this is 120 degrees. And then let's draw the other line from B. So let me align this again. Okay, this is better. So this bearing here is 195 degrees. So this is 195. And now this is the point C where these 2 lines intersect. So the point C has a bearing of 120 from A and 195 from this point B. So the intersection point will be the point C. The next part is find by measurement the actual distance in kilometers from A to C. So first we need to measure in centimeters and then we will convert it into kilometers. So let me use my ruler here again. And then position 0 at point A. So this is almost 3.5 centimeters. So this point C, so the length AC equals to 3.5 centimeters. So we know that 1 centimeter is 80,000 centimeters in real world. So let me first convert it into kilometers. So 80,000 centimeters divided by 1000 and then 100. So this will convert into kilometers. So let's use the decimal value. So AC is 3.5. So I have centimeters ratio kilometers. So 1 centimeter is 0.8 kilometers, and then 3.5 centimeter will be 0.8 into 3.5 kilometers, which is 0.8 into 3.5 is how much? This is 2.8. So this will be 2.8 kilometers, and your final answer here will be 2.8. So basically you've already have this in centimeters, the conversion. So 1 centimeter is 80,000 centimeters in real world, which is basically 80,000 divided by 1,000 multiplied by 100. So you convert 80,000 centimeters, you first divide by 1,000 to get meters, and then you divide by 100 more to get into kilometers. Sorry, it's the opposite. You divide by 100. So you have, this is centimeters. So you divide by 100 to get first into meters and then divide by 1000. This will give you 0.8 kilometers. So 1 centimeter is 0.8 kilometers in the real world. So 3.5 centimeter, which is this length AC, will be 0.8 times 3.5, which is 2.8 kilometers. So your distance of point C from A is 2.8 kilometers. The next part is the diagram shows the position of boats A and B and this harbor H. AB is 4 kilometers, AH is 6 kilometers, and this angle is 70 degrees. Part 1 is calculate the angle AHB. So this is the angle that you need to calculate. So if you look at this triangle AHB, you know this angle and the opposite side. You need to calculate this angle, but the opposite side of this is known. So we can use the sine rule here. So this will give us sine of AHB divided by the length AB equals to sine of this angle ABH, sine of angle ABH divided by this length AH. So let's substitute the values. We will get sine of AHB will remain the same as this angle is unknown. AB length is 4. Sine of ABH will be sine 70 degrees divided by AH is 6. So let's continue up here. So this will be sine of AHB will be, let's calculate this, sine 70 divided by 6 and then multiplied by 4. So this is 0.626, 0.62646, and then we take the sine inverse of this. So you get 38.78. So you will write up till 1 decimal point. So this will be 38.8 degrees. Part 2 is a boat. The boat at A travels in a straight line to the harbor at H. So this boat A moves in this direction towards the harbor. The average speed of the boat is p kilometers per hour. It takes 12 minutes and 20 seconds for the boat to travel from A to H. Calculate p. So p is the speed. So your speed will be distance over time. So distance divided by time. So you know the distance is this 6 kilometers. The time is in minutes and seconds. So time equals to 12 minutes and 20 seconds. So first we need to convert this into hours before we can put this in the equation here. So 12 minutes, how you convert minutes into hours? You divide by 60, plus you have 20 seconds. So you divide the seconds with 3600 because each 1 hour has 3600 seconds. And this will give you the answer, the time in hours. So 12 divided by 60 plus 20 divided by 3600. So this is 0.2056, you can say. So this is 0.2056. In fact, if you want, you can use the fraction value here as well. So let's try that. So let me in fact write this in fraction, which is 37 over 180 hours. So this is 37. So now your distance is 6 divided by your time in hours is 37 over 180. And then if I bring this up, I'll take the reciprocal. So this will become 6 multiplied by 180 divided by 37. So let's calculate this. 6 into 180 divided by 37. So this is up till 3 significant figures, 29.2. So your speed is 29.2 kilometers per hour, which is your value of P. Question 7. The table shows some values for y equals to 1 plus 2 over x given correct to 2 decimal places where appropriate. So you have x values and y values. Complete the table. So the value missing is for x equals to 8. So let's substitute x equals to 8 in this equation. So I will get 1 plus 2 over 8, which is 2 divided by 8 plus 1. So this is 1.25. Draw the graph of this equation for x between 0.5 and 8. So let's plot these points. So on x-axis, each small block is 0.1 and same on y-axis as well. So first value is 0.5 and 5. So 0.5 and 5 is this point. Then you have 1 and 3. 1 and 3 will be this one. 2 and 2. 3 and 1.673. This is 1 on y-axis. This is 1.5, 1.6, 1.7. So it's between 1.6 and 1.7, but more towards 1.7 since the value is 1.67. Then you have 4 and 1.5. 4 and 1.5 is this. 5 and 1.4, which is this. 6 and 1.33. 6 and 1.33. 1.1, 1.2, 1.3, just a little above 1.3. 7 and 1.29. So 1.29 is just below 1.3. 8 and 1.25. 1, 1.2. So right between 1.2 and 1.3 will be 1.25. So this will be the plot. So let's draw a smooth curve for these points. So this will be your curve for this equation. Part C is the line L crosses the graph of this equation at x equals to 2 and x equals to 5. Find the equation of L. So we are given that it crosses the graph that we have drawn at these 2 points, x value 2 and x value 5. So at x equals to 2 and x equals to 5, we already know the y values. So the coordinates of these 2 points where the line L crosses the graph are 2 and so when x is 2, your y value is 2. And then when x is 5, your y value is 1.4. So these are the 2 points for this line L. And now we can find the equation. So your formula for equation is y minus y1 equals to gradient, which is y2 minus y1 over x2 minus x1 into x minus x1. So we can take any of these points. So let's call this x1 and y1, and let's call this x2 and y2. And then we can substitute these values here. So let's substitute the values here. So y minus y1 will be 2, y minus 2, then y2 minus y1 will be 1.4 minus 2 over x2 minus x1 will be 5 minus 2 into x minus x1 is 2. So let's open these brackets. So 1.4 minus 2 will be minus 0.6. So this will be y minus 2 equals to minus 0.6 divided by 3 into x minus 2. So let me continue here. So this will be y minus 2 equals to minus 0.6x over 3 plus 2 into zero point 0.6, which is 1.2. 1.2. And then if I take this, so you'll divide by 3 here as well. So minus 0.6 over 3 is being multiplied in here. So this will be y minus 2. So in fact, I can take this minus 2 to the other side. So I will get minus 0.6 over 3 times x plus 1.2 divided by 3. So 1.2 divided by 3 is what? 0.4. So this plus 2 plus this 0.4, I will get plus 2.4. And then you can also convert this into decimal. So 0.6 divided by 3 will be minus, sorry, 0.2. So minus sign as it is. So this will be y equals to minus 0.2x plus 2.4. So this will be your final equation of the line. Y equals to minus 0.2x plus 2.4. Part D is a line with gradient minus 1 over 3 crosses the graph of y equals to 1 plus 2 over x when x equals to 1 and when x equals to k. By drawing a suitable line on your grid, find k. So there are two ways to solve this question. I'll show you both. Uh, the first one is using the first, like finding the equation of the line and then drawing it on the grid. And second method is we can draw this directly on the grid as well and then find the value of k. So I'll show you both. So for the first method, you're already given the gradient. Gradient is minus 1 over 3, and you can find one point on the line because we know that the line passes through this, crosses this equation, line of this equation. So the line of this straight line will intersect this curve at x equals to 1. So when x equals to 1 for this curve, your y value is 3. So that means the line passes through this point 1 3. So you have one point on the line which is 1 and 3. So you can find the equation of this line easily, which is y minus y1 equals to gradient, which is m into x minus x1. So we can call these points x1 and y1 and then substitute the values. Y minus y1 will be y minus 3 into gradient is minus 1 over 3 into x minus x1 is 1. And then if I open these brackets, I will get minus 1 by 3x plus 1 over 3 plus 3. And then you will have y equals to minus 1 over 3x. 1 over 3 plus 3 will be, let's calculate this. 1 over 3 plus 3 is 10 over 3. So now you can find another point on this equation by like substituting any other value of x. So let's substitute, we have x equals to 1. So let's substitute x equals to 3. So when x equals to 3, your y value will become minus 1 over 3 into 3 plus 10 over 3. So this 3 and 3 will cancel out, and then you subtract 1 from this. So you'll end up at 7 over 3. 7 over 3. So 7 divided by 3 is what? 2.33. So this is 2.33. So you have another point, x is 3, this 3, and then y value is 2.33. So now you have 2 points, 1, 3 and 3, 2.33. You can plot these. So 1, 3 is here, and then 3 and 2.33 will be uh, this point here. And then you can join these 2 points and extend the line to get the intersection point. So your line will go like this. It intersects here. We already know that. And then you continue through this point here, which is y value is 2.3, and you continue the graph and see where it intersects this curve again. That will be your value of this value k. The other quick method is you can simply straightly like go to the graph. You know the gradient is minus 1 over 3. So gradient is what? Gradient is minus 1 over 3. That means this is delta x, delta y over delta x, right? So that means you go negative 1 in y direction. So if you have this point 1 3 on the graph that we know lies on the line. We know that it touches this curve at x equals to 1 where the y value is 3. So from this point you go negative 1 in y direction. So negative 1 you will end up here, and then you go positive 3 in x. 1 2 3. So you get to this point here. So forget about this point. This was using the other method. So you can straight like get to this point using the gradient. And now you have 2 points. This point 1 3 and this point which is 4 2. And then when you directly like draw the line, you can get the intersection point. So let's draw this line as well, which passes through these 2 points here. So let me try this again. Let me actually start from this point. And then the line passes through this point, like this. So using the gradient, you actually found the other point on the line directly using delta y over delta x. One, -1 in y and positive 3 in x. So if you find the gradient using these 2 points or any other points on the line, you will get this given gradient in the question. So where does it intersect? This is the intersection point of the line and this curve, and the x value here is 6. So your value of k here, which is the x value, x coordinate, will be 6. Question number 8 is the mass in grams of each of 75 oranges is measured. The results are summarized in the table. So you have different classes of mass, 160 to 170 gram. You have 4 oranges. From 170 to 180 grams, you have 10 oranges, and so on. Part A is one of these oranges is chosen and at random. Find the probability that it has a mass greater than 200 gram. So where are the oranges which have masses that are greater than 200 grams? So this is the class where the masses are between 200 and 210. So we will count these. And then this is the class which has also masses greater than 200 grams. So this is between 210 and 220. So these are 5. So number of oranges with mass greater than 200 gram. How many are there? 18 plus 5. 18 plus 5, which is 23. So now probability that you find an orange, if you pick an orange that the mass is greater than 200 gram, there are 23 such oranges out of total 75. So your probability is 23 over 75. Part B is calculate an estimate of the mean mass. So let me erase this. I can draw a couple of more columns here. So to calculate the mean, you will need the mid values for these classes. So let me write down the mid values and let's call those x. So the mid value here will be 165. This will be 175, 185, 195, 205, and 215. So and then you will find their product. So this will be fx, where frequency is f and x are the mid value. So 160 times 165 times 4 will be 660. So this value here will be 660. 175 times 10 will be 1750. 185 multiplied by 15 will give you 2775. Then you have 195 multiplied by 23, 4485, 4485. 205 multiplied by 18 is 3690. 3690. And then 215 times 5 is 1075. 1075. So your mean value will be sigma fx, which means you add all these products of f times x divided by sigma f, which is the sum of all these frequencies. So sigma fx will be 660 plus 1750 plus 2775 plus 4485 plus 3690 plus 1075, and divided by the sum of all frequencies is basically the total number of oranges, which is 75. So now if you add all this, 660 plus 1750 plus 2775 plus 4485 plus 3690 plus 1075. So this is 14,435 divided by 75. So this divided by 75 will be 192.5 up till one decimal place. In fact, you will have to write it up till three significant figures because this is a non-exact answer. So this will be 192 and the next value is 4. So I will not round this up to 3, so it will remain 192. So your mean value is 192 grams. Part C is on the grid. On the next page, draw a cumulative frequency diagram for the mass of oranges. So let me redraw this table here. So you have mass, frequency, and then you need cumulative frequency now. Cumulative frequency column as well. So you have classes starting from 160 going up till 220. So this will be 160 m less than equal to 170. Then you have 170, 180, 180, and then 190. This will be 200. 210, and then 210, and then 220. So the frequencies are 4, 10, 15, 23, 4, 10, 15, 23, 18, and 5. 18 and 5. So let me actually draw these lines as well. So cumulative frequency will be the sum of all frequencies up till that point. So we're starting here. So cumulative frequency here is 4. Here this is 10 plus previous cumulative frequency, which is 4, so 14. Then you have 15 plus 14, you will have 29. 23 plus 29 will be 52. So this will be 52. And then 18 plus 52 plus 18 is 70 here. And then you have 70 plus 5, which is 75. So 4, 14, 29, 52, 70, and 75. Okay. And then we can plot this on this grid here. So you always, for the cumulative frequency, you take the upper bound of the class. So your first point will be 170 and 4. So 170 is here, and the 4 value on y-axis will be this one. Then you have 180, and the cumulative frequency is 14. So 180 and 14 will be this one. Then you have 190 and 29. 190 and 29 will be this one here. And then 252. 252. 210 and 70. So 210 and 70 will be this value. And the final value is 220 and 75. It will be this value here. And then since there are no oranges which have mass less than 160, so if you want, you can uh, assume another imaginary class here, which is m is less than 160. How many oranges? 0 in this, because your mass starts from this class 160 to 170. So there are 0 oranges less than 160 grams in mass. So you can plot this 160 value and on x-axis and y-axis value will be 0. So now you can draw this cumulative frequency curve. Let me try this again. All right, this is better. So this will be your graph for the cumulative frequency. Part D is use your graph to find an estimate for the median. So for the median, first we need 50% of the total frequency, 50% of 75 because there are 75 oranges. So this will be 75 divided by 2, 37.5. So we have to find the mass when the frequency value, cumulative frequency value is 37.5. So this is 35, 36, 37. So 37.5 will be here in the middle of this small block. So I'll draw a line here and see where this intersects our cumulative frequency curve, which will be the median value. So it looks like it's this value here. So this value here is 191, 2, 3, 4. So this is 194 grams. So your median value is 194. Part E is oranges with a mass of more than t grams are labeled class A. 20% of the oranges are labeled A. Use your graph to find T. So that means the 20% of oranges, if you sort them from masses, so if you have low mass, low mass to highest mass of an orange, so the top 20% of the oranges are labeled class A, and your mass value here is some t grams, right? So all the oranges that are above this t grams are labeled class A. So let's first find how many oranges are labeled class A, and then we can use our graph to basically eliminate those top oranges and then see what is the mass value from this cumulative frequency curve, which represents this value t. So let me first find this 20%. So 20% of 75, which are the total oranges, will be zero point 0.2 into 75. This is 15. So if you subtract 75, so if you subtract 15 from 75, you get 75 minus 15 will be 60. So that means I have to look for the value when cumulative frequency is 60. So this is the line which represents y value of 60, and it intersects the graph at this point. So this value will be 200, 1, 2, 3, 4. So this value here is 204. So all the oranges from 60 up till this point 75, they are labeled class A. So their masses are greater than this mass. So all the masses to the right are greater than 204 grams. So all the oranges that are greater than 204 grams in mass are labeled class A, and there are 15 such oranges because we're given 20% of the oranges are labeled class A. So your value of T is this 204 grams, which is the mass above which all the oranges are labeled class A. Part F is oranges with a mass of 178 grams or less are used to make orange juice. Use your graph to find an estimate for the number of these oranges that are used to make orange juice. So the mass is 178 grams. So if you look at 175, 176, 7 and 8. So this is 178 and we have to find the number of oranges. So it intersects the curve at this point. So let's find the y value will be 11. So there are 11 oranges here which have masses 178 grams or less. So the number of oranges that are used to make orange juice are 11. Question number 9 is the diagram shows a triangular prism. This length AC is 15 centimeter, BC is 14, and this angle here is 27 degrees. The first part is calculate the length AB. So this length AB that we need to find. So if you look at this triangle ABC, we know two of the sides and we also know the angle between them. So we can use the cosine rule, which will give us AB square equals to AC square plus BC square minus 2 times AB into BC into cos of this angle BCA. So cosine of angle BCA. So let's substitute the values. AB is the unknown, so AB square equals to AC is 15. 15 square plus BC is 14, so this will be 14 square minus 2 times 15 times 14 times cos of 27. So this will give us AB square. So let's calculate that. It's 15 square plus 14 square minus 2 times 15 into 14 into cos of 27. So this is 46.777. So 46.777. And then AB will be the square root of this. So square root of answer. So this will be 6.84 in three significant figures. So 6.84 centimeters. Part B is the length of the prism is P centimeter and the volume of the prism is 1000 centimeter cube. Calculate P. So this length of the prism is P and the volume is given. So if I take this triangle ABC as the base of this prism, I can find the volume by simply multiplying the base area with the height. So this length will become my height. So let me show you what I mean here. So I'll bring in this prism. So this is the same prism here. So this point is A, this is B and C. So I've basically flipped it into this upright position. So this along this line, you can say I've rotated it along this line. So this is now vertical rather than horizontal. And now my triangle ABC is my base. So my volume will be the base area multiplied by the height, which is now P. So volume of prism is basically area of triangle ABC multiplied by the height, which is P. So volume is given as 1000. I can find the area of this triangle, which will be 1 by 2 into these two sides multiplied by the sine of angle between them. So 1 by 2 into 15 into 14 into sine of 27 times P. So this 2 and this 14 will cancel. So 2 times 7 is 14. So P will be, I will take everything to the other side except P. So all of these will go in the denominator of 1000. So 1000 divided by 15 into 7 into sine of 27 degrees. So this will give you the value of P. So let's calculate this. 1000 divided by 15 into 7 into sine of 27. So this is 20.98, or I can also write it as 21.0 to write it in three significant figures. So this is P is 21.0 centimeters. Part C is the prism is to be packed in a carton. The carton is a cuboid of size 15 centimeter by P centimeter by H centimeter. Calculate the smallest possible value of H. So now you're packing this this prism in a cuboid carton. So let me draw a cuboid around this in which we will say we are uh, packing this prism. So this will be one side of my carton, which is given 15 centimeter. And one other dimension also given is this side, which is P centimeter. So carton is 15 by P by H. So this side is 15, and then this side is P centimeters. So let me align this here like this. And then let me just complete the cuboid around this prism like this. So this is the front side, and then I'll draw it to the back as well to make it look like a 3D shape. And then the final line will be this one. So now this is your cuboid carton in which you are trying to fit this prism. So your one side of the carton is 15, this side is P, and then this is the third dimension of the carton, which is H centimeters. So to now perfectly pack this carton, uh, uh, I have this side which is 15, which is fine. This prism will fit because the prism side is also 15 centimeter. Then this side is both prism and carton are P centimeter, so this dimension will fit as well. So now we have to find the minimum possible value of this side H. So the carton, this side at least has to be this high so that this triangle will fit inside this carton. So this H is basically the exact same height as the height of this triangle. So this is also H. Now if I look at this triangle that is formed, I have this side 14, which is the hypotenuse. I have this side, which is making a 90-degree angle here. So this is the perpendicular height of this triangle. So I can use sine of this angle. So let me write it here. Sine of 27 will be equal to this height h, the perpendicular over the hypotenuse, which is 14. So this will give you the minimum height of h that is required such that this prism will fit in this cuboid. So let's calculate that. So sine of 27 will be h over 14. And let's calculate h here. Sine 27 multiplied by 14. So this h will be 6.36 in three significant figures, 6.36 centimeters. Question number 10 is you're given f and g. The first part is find g minus 2f. So g minus 2f will be equals to g as it is minus 2 times f4 minus 3, and then I'll multiply this 2 inside. So I'll get 1 minus 5 minus, and then 2 times 4 is 8, and this is minus 6. So this will be 1 minus 8 minus 5 plus 6. So this will be minus 7 and 1. Part 2 is Petra writes that magnitude of f is greater than magnitude of g. Show that Petra is wrong. So we can calculate the magnitudes and then uh, compare the values. So magnitude of f will be square root of 4 square plus minus 3 square. So this is 16 plus 9. So this is square root of 25. And then magnitude of g is 1 square plus minus 5 square and then whole square root. So this will be 25 and square root of 26. So definitely square root of, let me write it here, square root of 26 is greater than square root of 25. So magnitude of g is greater than magnitude of f, and Petra is wrong because she said magnitude of f is greater than magnitude of g. So can say Petra is wrong. Part B is OAB are points with OA vector is as A, OB is B, P is the point on OA such that OP is 1 by 3 times OA. So if this full length is 3, then OP is one part, and then this length PA will be two parts. So OP will be 1 by 3 of this full length OA as given here. OQR lie on a straight line, and Q is the midpoint of PB. So Q is this, Q point is midpoint of PB. So PQ and QB will be equal. First part is find PB in terms of A and B. So PB is this vector. So I can write using the head to tail rule. PB will be PO plus OB. And PO is minus OP. OP in this direction, so PO will be minus OP plus the same vector OB here. And then I know that OP is 1 by 3 times OA, so this will be minus 1 by 3. OA is this vector A, so minus 1 by 3A plus OB is this vector B. So PB is minus 1 by 3A plus B. Part 2 is find OQ in terms of A and B. So OQ is this vector here. So we know that OP is 1 by 3 times this vector A. And then we know that PB is this, and we are given Q is the midpoint. So I can write OQ. So using the head to tail rule, I can write OQ can be written as, let's see, OP plus PQ. So OP plus PQ, and then PQ we know is half of this PB, right? We're given that Q is the midpoint. So this will be OP plus half of PB. PQ is half of PB. So OP is what? OP is this vector here, which is 1 by 3 times this vector A. So OP is 1 by 3A plus half times PB is this vector minus 1 by 3A plus B. So let's open this bracket. So 1 by 3A as it is, then this will become minus 1 by 6. So this will be minus 1 over 6a and then plus 1 over 2b. And then we can take the LCM here. So LCM will be 6. This will be 2a minus a plus 1 by 2b. And then this will be 2a minus a will be 1 by 6a plus 1 by 2b. So OQ can be written as 1 by 6a plus 1 over 2b. Part 3 is QR equals to 2OQ. So QR is 2 times OQ. So that means, again, if this full length is 3 parts, then this will be 1 part and this will be twice. So QR is given as 2 times OQ. So this will be 2 parts. So this QR is double this OQ, and then this full length becomes 3 parts. Show that AR is parallel to PB. So AR is this length, PB is this length, and we have to show that these two are parallel. So there are two methods to solve this part. I'll show you both. The first one is using the vectors, and the second one is using similar triangles. So let's first use the vector method here. So to show that AR is parallel to PB, we have to basically show that we can write the vector AR as some constant k times PB. If we can show that, that means these two vectors AR and PB will be parallel. So we already know PB. We have to find the value of AR, then compare the two. So AR is this vector here. So let me mark this in yellow. And then using the head to tail rule, I can basically write AR as this vector AO plus this vector OR. And to find OR, we know the value of OQ, and this is OQ. That means if I multiply it by 3, I will get this full vector OR, because this is 1:2 and then this is 1:3. If you compare, I'm comparing OQ with this OR. So this, if this is 1, this is 3 times. So this is 3. So if this is OQ is this, which we calculated in the previous part, OQ is 1 by 6a plus 1 over 2b, then OR will be 3 times this OQ. So let's first find AR. AR is AO plus OR. AO plus OR. And then AO is simply minus A, because OA is this value A. So AO is minus A plus OR is 3 times this vector OQ. OQ. And then if I simplify it further, minus A plus 3 times OQ. So I'll substitute the value of OQ here. This will be 1 by 6A plus 1 over 2B. So let's open this bracket. So this will be minus A plus this 3 ones are 3, 3 twos are 6. So this will become 1 over 2A plus 3 over 2B. 3 over 2B. And this will become minus A plus half A will be minus half A. So I can write this as 3 by 2B minus 1 over 2A. So this is my vector AR. So now I have to write AR equals to some constant k times PB. So let's substitute the values. AR is this, which is 3 by 2B minus 1 by 2A. And k times PB is what? PB is B minus 1 by 3A. So since I have B here first, I when writing PB, I wrote B here first as well. So to make the comparison easier. So now if I take 1 by 2 common on this left side, so let's take 1 by 2 common. I'm left with 3B minus a here. And if I take 1 by 3 common here, so this will be k into 1 by 3. This b will become 3b, because if I bring this back in, this 3 and 3 will be cancelled out and I'll be left with b again. And this will be 3b minus a. So this is 3b minus a here. This is also 3b minus a here. So that means these two values should be equal, right? So I can directly compare these to find the value of k. So 1 by 2 should equal k by 3. So I can write this as k equals to 3 by 2. So that means the vector AR is 3 by 2 times PB. So they are parallel. So this was the vector method, using vectors to basically prove that they are parallel. Now I'll show you another way to do this, which is using the similar triangles property. So if you look at this triangle OPQ, so triangle OPQ, let me draw this here, and the triangle OAR. So this is OAR here. We can show that these two triangles are similar using the SAS property. So this angle here is common. And if I look at the ratio OP over OA, this length OP over this full length OA. So this is 1 over 3. OP is 1, OA is 3. And then if I look at this ratio OQ over OR, so this OQ over this full length OR, OQ over OR, again this is OQ is 1 and this full length OR is 3. So we have shown that the ratio of OP over OA is equals to the ratio OQ over OR, and the angle between them is same. Angle POQ equals to angle AOR. It's the common angle. It's the same angle. So common angle. So that means that these triangles are similar. So which is the third side? Third side is this PQ over AR. So this PQ over AR should also have this same ratio, right? 1 over 3. But we are interested in the comparison of PB with AR. So I can write this PQ. PQ is half of this full length PB. We know that Q is the midpoint. So if I have PQ, if I have to write PQ in terms of PB, I can write this as 1 by 2 times PB over AR equals to 1 over 3. And then I can, what I can do is I can take this AR to the other side. So I will get 1 over 2 PB equals to 1 over 3 AR. And then I can, so let me draw the partition here. So I have to represent AR in terms of K times PB. So I can bring this 3 here. So this will be 3 by 2 PB equals to AR, right? So again, K equals to 3 by 2, which is the same value that we found using the vector method. So again, we have written, let me bring this down. So we have written AR equals to 3 by 2 times PB. So it's a constant K times PB. So AR and PB are parallel. So you can use either method. Either you can use vectors to show this, or you can use the this similar triangle property to find the ratios of the two sides, and then the ratio of the third sides is also similar. So we basically compared PQ with AR here, and then we wrote PQ in terms of PB. So both methods will give you the same answer, and you can prove that AR is parallel to PB. Question number 11 is f of x is given and then g of x is given. The first part is find g of 2. So g of 2, I'll substitute 2 here instead of x. So this will be 7 into 2 over 4 minus 1. So this will be 14 over 4 minus 1. And this will be 14 minus 4 over 4. This is 10 over 4, which is 2.5. Find g inverse of x. So we let y equals to g of x. So this gives us, if I take this g to the other side, g inverse of y equals to x. So let's use this to write g of x and then make x the subject of the equation. So g of x is 7x over 4 minus 1. So this will give me y plus 1 equals to 7x over 4. And let me continue up here. If I take this 4 to the other side, I will get 7x equals to 4y plus 4. And then x will be equal to 4y plus 4 over 7. And we know that x is g inverse of y. So instead of writing x here, I'll write g inverse of y equals to this 4y plus 4 over 7. And then I can substitute x instead of y. So g inverse of x will be 4x plus 4 over 7. So this will be 4x plus 4 over 7. Given that f of t is 6, find t. So f of t will be 3 into, I'll replace x with t minus 2. And this is given as 6. So this is 6 equals to 3t minus 6. And then if I bring this 6 to the other side, I get 3t equals to 12 and then t equals to 4. Part D is f of 7x over 4 minus 1 equals to px plus q. Find p and q. So we are given f of x is this. So to find f of 7x over 4 minus 1, I'll substitute this value here instead of x. So f of 7x over 4 minus 1 equals to, let's substitute the value here. So 3 into 7x over 4 minus 1 and then minus 2. And this will be 3 into 7x over 4 minus 3. And then if I open this bracket up, I will get 21x over 4 minus 9. So f of 7x over 4 minus 1 is 21x over 4 minus 9. And we are given that this is px plus q. So px plus q will be 21 over 4x minus 9. So if I compare the two sides, the coefficient of x is p, and here the coefficient of x is 21 over 4. So my value of p will be 21 over 4, and q is the value with no x or any other variable. So this value here is minus 9. So q will be minus 9. So p is 21 over 4 and q is minus 9. So this is the end of paper 2 variant 2 for May June 2019.